All right, I think we'll get started. So thanks for joining us, everyone, and welcome to today's discovery session. These sessions are meant to support students, businesses, and other organizations with an understanding of how to use data and artificial intelligence. But before we get into it, I'd like to begin by acknowledging that DeepSense works out of Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the Treaties of Peace and Friendship, and we'd like to recognize the Indigenous peoples of all the lands that we are on today. We want to ask that everyone takes a moment to consider the territory in which that they are situated and their own personal responsibility in the processes of reconciliation. My name is Alyssa, and I'm the communications specialist with DeepSense. For those of you that don't know what DeepSense is, let me give you a little bit of an introduction. DeepSense is a project based out of Dalhousie University in Halifax, Nova Scotia, but we work with universities and colleges all across Atlantic Canada. We work with companies in the ocean sector who are interested in harnessing the potential of data and creating a smarter ocean economy. We connect these companies with the next generation of AI, machine learning, and data experts, aka our students. We work with companies to create a project that best suits their needs, and then we find a researcher and a student to help execute this project either as a master's research project, a co-op, or an internship. We've had past projects in data analytics, data collection, data visualizations, data cleaning and processing, and of course, AI and machine learning. Projects could be anything from creating a deep learning model to track fish, creating a prediction model for safe navigation in the Halifax Harbor, or even a computer model that can identify whale shapes from aerial images. If you've ever wanted to grow your skills and work on real projects and gain industry experience, and you're a student, then make sure you submit your information to our student pool. Projects and internships and co-ops pop up throughout the year, so it's useful to throw your name in there because this is the first place that we will check to find someone to fill a position. I'll share the link to the student pool in the chat just after I finish up talking. And make sure that your resume is rocking because you want to stand out, since only those selected for an interview will be contacted. So for today's session, we will be learning all about automated machine learning, also known as AutoML, on cloud. AutoML is a powerful tool that's quickly changing the AI landscape. We'll discuss how AutoML on cloud platforms such as AWS allows users to easily create AI models while reducing the complexity associated with traditional machine learning methods. While we discuss the advantages of AutoML, such as increased efficiency and reduced errors, we'll also cover the most important limitations and critical considerations, such as data privacy. AutoML represents a significant advancement in AI and will provide insight into how it can be effectively implemented in a variety of domains, including ocean research. And today's session is led by Prakrut, our cloud engineer here at DeepSense, headquartered at Dalhousie University. At DeepSense, Prakrut is responsible for working on AWS, Azure, and Google Cloud, managing cloud infrastructure and setting up high-end instances for machine learning training on various cloud services, and troubleshooting GPU and machine learning environment issues on cloud. Prakrut has a bachelor's degree in computer engineering and has also previously worked as a freelance developer. He recently finished his master's in applied computer science at Dalhousie University. He's worked on several machine learning projects in the healthcare field and was a member of Google Developers Group, where he gained interest in cloud. He grew up in the capital city of Gujarat state in India, where he found a love for the environment. He enjoys traveling, especially exploring new places and hiking, as well as photographing the frames creatively from his perspective. If you have any questions throughout the presentation, we'll be taking them at the end, but feel free to either drop them in the chat or pop them in the Q&A box at any point during the presentation. Or you can go ahead and unmute yourself to ask your question at the end. And that is more than enough for me. I'll drop the link to the student pool in the chat, and let's hear from Prakrut.
Yeah, thank you, Alyssa. Thank you, everyone, for joining. Let me just share my screen and we can get started. Yeah. So today our topic is to discuss about the AutoML on cloud. So most of people have heard about it and already may be using it, and it's a totally same thing as a machine learning, but now the cloud is doing on itself. So today the topics we'll be covering are we'll discuss about the AutoML. Then we will go through the problem of traditional ML. Then we'll discuss the AutoML tools, which are the AutoML tools are available on online, and which are the open source tools that you can use other than AWS and Google and Azure. Uh, Also about the benefits of AutoML and using different cloud providers, like I said, AWS and Azure. We can use the AutoML, and we're going to also be doing a demo session, so it will be really good. Also, we will discuss about the cost implications and limitations and the future of AutoML. And yeah, so let's get to what is AutoML. So for starters, we can explain everyone might know what is machine learning. So basically it's the raw data that is you can see in the right side of the diagram. And so it starts with the raw data, and we do the data cleaning, and you select the features. Features are basically the columns that are available in your data set. So you do the feature processing and feature selection and feature construction, and then after you select the model. So usually we do go through various models and select from there, and do parameter optimization and other stuff, and then we validate the model. So as you can see, the whole process of doing the hard work that is being done in the notebook that is provided by Jupyter Notebook or anything on Google Colab. We can do it by ourselves. That's a manual work. So that's not like it's very time consuming, and we have to hire data scientists, and we can go from there, and just they have to work on that, and it's a very lengthy process. So what we have on cloud is the AutoML, that is a process of automating the end-to-end process that is given here. And it is helping to build the machine learning models. And it also includes the tasks such as the data processing, feature engineering, and the model selection. Also the hyperparameter tuning. So yeah, that's basically the explanation of AutoML on cloud. For the importance of AutoML, the it's also very helps the users to transfer data, and training algorithms, and automatically search for the best neural network. And yeah, it saves the data science practitioner a huge amount of time. As I said, it often takes a task to would take hours to complete, that can be accomplished in a minute. And also, I would say there are projects that are very longer in the duration, for like that took hours, maybe days, but it can be done very fast in the AutoML. And do you see any background noises, Alyssa?
No, we're all good.
Okay, because there's construction going on here, so it's a little bit. Yeah, so for the next thing, we will discuss how the traditional ML training flow is different than the AutoML workflow. So for starters, the machine learning problem that we have, we discuss about that, and we collect the data, and then we process the data. This whole process is done by any of the data scientists. So the pre-processing data, training model, and evaluation can be done by the data scientist, but everything will be done inside the AutoML. And after we collect our data, we just feed that to the cloud and the AutoML, and it does the magic, and everything goes really great after that. Yeah, so what are the problems with traditional ML workflows? So first, the workflow, as we discussed, the data collection, the data processing, and the model building, and also the evaluation after we build the model. So for the challenges in traditional ML projects are like if you are a beginner or have limited knowledge about ML, you can't just go ahead and work on an ML project and just train the models by yourself. We have to gain a little bit of knowledge. So we can just remove that part and just have everything on this machine learning, like the AutoML, and it will do our jobs for doing everything that is mentioned here. So yeah, that's the advantage of AutoML. And the problem with the traditional ML, it solves the problems of that one. So yeah, and the question that we most have, that what is the role of domain expertise in ML? So as I said, there are vital roles that provides insight to the problem and guiding the selection of the appropriate algorithms and feature engineering techniques and evaluation metrics. So everything that is done by the data scientist can be now done by the AutoML, and we don't need that much of technical knowledge to just train the model and just have it everything on the AutoML. And yeah, this is the history of the AutoML, that it's just started in 2012, but there wasn't that much feedback from people. So first started by H2O.ai, and it's still uh, encouraging by AWS. That AWS also have some of the marketplace images from the H2O.ai that currently they are using. Then after Teapot has came into picture, and they also launched their AutoML. And then after AWS and Google came together, not together, those are different, and they launched their own AutoML. And after that, Azure has came into picture. Okay, so what are the components of AutoML? So as I said, the data processing, feature selection, algorithm selection, and hyperparameter tuning. So everything will be automated in the AutoML. So first, the data processing that involves tasks such as data cleaning, normalization, and transformation to prepare for data analytics. So that is everything just done now, just on the click of button. So also for the feature engineering, that includes automating the process of generating features from raw data, and which is crucial for improving performance of the machine learning models. So that is also available in AutoML. So after that, we have model selection that we discussed that usually we need more of the algorithms to check for the whole our data set. So we check multiple models there. So that is also done by the AutoML, and they select it by automatically. And then after, also the hyperparameter tuning is done with the AutoML, and it's significantly effective than we do manually, because it has more analysis than the human mind. So it does a better job than humans also. So yeah, the working of AutoML. So AutoML process involves the iterative training models. So as we discussed, like we have to train multiple models on the same data set. We have to do that by ourselves, and we have to be doing that with the subsets of data and varying the hyperparameters, and until we got the best performing model. So that is very time consuming, because every time we do that on notebook, we have to run everything that is on that model and wait for the outcome. And we don't know which instance or which GPU that will be very beneficial to us. And uh, uh, figuring that all out, it takes a really long time. And that's why we can use AutoML, that is also using the other instances that are being used in background, and we can do that automatically. So it auto scaling on the requirements. And yeah, it AutoML also uses multiple tools and libraries, like we have AutoSklearn and AutoKeras and Teapot that are very that offers really great and different features and capabilities to automating the ML process. So as you can see, it can run every model that is suitable for your data set. So new bias, SVM, cat boost, and everything whichever you think of. And yeah, this is the diagram that we can go through, and that shows for the customer data. There's a data splitter here, and this is whole inside the whole thing is doing inside the AutoML. So first is training and validation, the folds, and it runs a pipeline of that recommender and processing the jobs inside various Jupyter notebooks. And yeah, this will be multiple. This also supports multiple instances. So yeah, it does the parallel processing and transforms data by the pipeline, and we can do multiple jobs at a time. So that's why it's here, it's doing X 10x jobs at once. And it also does the tuning job, training job into 250. So these are the list of the models that is uh, processed parallelly to all the processes. So we don't have to wait longer. We just need a higher instance that will run for a smaller time. So it will be very beneficial to us for time and also for the cost aspect of the AutoML. So yeah, as I said, there are few tools that we can use uh, that's available on the open source online. So as you can see, we use Keras in most of our machine learning modeling, and there's also sklearn library that we can use. Now they have launched the AutoKeras, as we have the same thing that we're doing, and we are testing out in ourselves the manual work. It has been done by the sklearn and Keras automatically. So whichever we think that features, like we want to do automatic model architecture search, hyperparameter tuning, and support for various neural networks layers and activation feature functions. So that is also available in AutoKeras. So the use case of AutoKeras can be utilized in image classification, sentiment analysis, and speech recognition tasks, and many more. And after that, we have AutoScaler. As everybody will know, if they are data scientists, that it is also used to in a various tasks such as predicting house prices, classifying the text documents, and forecasting stock prices, and many more. So these are the open source Python libraries that we can use to just use it on our traditional ML, and that can be done automatically with this automated tools. So this falls to our benefits of AutoML. So we can go from the first, that it skips the ML legwork and jump into prototype and market fit test. It also always in the scope, because you are providing your data set and you're providing the features that are going to be in that data set. And then after you select the target value, so everything will be in scope, and we don't get uh, uh, we don't get misdirected by any of our manual works. The relatively affordable in case of hosted AutoML, because as I said, we run like multiple models, uh, and we do it by manually, and then we have to wait for hours to complete that process. And the same thing AutoML does is just doing everything parallelly, and that saves our time and also saves money, because it uses high-end instances, but it's run for a smaller amount of time. And thereafter, that's why we just can do that very in a short time of period. So that's why it's very affordable to host AutoML. Less experts required. As I said, it's very easy to use the AutoML. Anybody who doesn't has a background of data science or machine learning even other people who are non-tech people can also use it. They just have to select the database and provide the target values. It will be that easy for them. And it also allows collaboration and uses fewer resources. So the comparison that I found in a report, that data scientists spend 60% of their time for clearing and organizing the data set, and 90% of time to collecting them. So automated machine learning makes it easier to create and use models, and allowing you to focus on complex problems. So the traditional steps for developing machine learning are data collection, analysis, filtering, algorithm selection, and training, testing, and the repeating the process until we get the best fit for the algorithms. So that everything can be done by the data scientists, and data scientists can use it to save their time also. Yeah, and these are some other benefits of AutoML. So increased productivity, because you can focus on more complex tasks, and you can just automate the repetitive tasks that are going in machine learning. And while you creating your model, you can just focus on higher level problem solving. It's faster time to market, so it speed up the development process, and resulting in the models that can be deployed very quickly and reach better and very fast in the market. Also improved model performance. By automating hyperparameter tuning, you can just select the few of the buttons, and just it will be do it by itself. Uh, Feature engineering AutoML can lead to better performing models with less risk of human error. So yeah, whenever we do modeling for any of the machine learning problem, and we often come up to any human errors, that are like there none of the human errors will happen in AutoML. So that is the major plus side of the using AutoML. And also uh, it democratizes the machine learning by making it more accessible to individual without the extensive coding skills. Therefore, it's innovation and it's growing in the field. So yeah, for AutoML in the cloud, we have few options like AWS, Azure, and Google Cloud provides their support for AutoML. They also have different services for machine learning, like Amazon has the SageMaker Studio. Azure AI has their own machine learning studio, which can be launched with the machine learning workbench and that stuff. And Google Cloud also has the Vertex AI that can also use to do the AutoML thing, and also various other uh, machine learning modeling that can we do on the cloud. So for now, at our DeepSense, we use Amazon SageMaker Studio in most of our projects. So it provides us the notebook access. It also has the AutoML. So it also gives you better instances that are higher in the performance. So most of the instances we have are GPU ones. So it really does the great job, and we can also optimize the performance and cost, and we can save a lot of cost by using the SageMaker Studio rather than using any local hosted Jupyter notebooks. So it's very beneficial. So for AWS SageMaker Studio, the key features of SageMaker Studio included the AutoML training with autopilot experiments. So we will check this in our demo after the presentation. And it's straightforward to the model deployment and monitoring with auto scaling capabilities. So this is a diagram, the basic diagram that is being worked on behind the SageMaker Studio. So that's raw data when after we get that from S3. So we have to store all of our data on the S3 bucket, and then we can get that data on AutoML and use that data to do our model training. So this is the raw data, and then we have to select the target value and column that shall be used for the prediction. And it does the automatic model creation and finding the best algorithm to train it and turning it automatically. After that, it also provides us the notebook that which algorithm or which functions that it has used. So after that, we can also check out which are the exact thing that SageMaker Studio has worked on. And then it will also provide a list that how many algorithms that it has selected, and it has selected from the best. So, and after that, it deploys and monitors the model. So this is the whole life cycle of this SageMaker Studio's AutoML, and we can just have it look around in the demos after the presentation. So this is the basic components of the studio. It provides data. It also does the data cleaning and all the data things differently other than it's done inside AutoML. So there are a lot of other services that is available on the studio. We can also create pipelines and have it production ready. So we can use it in all ML ops that just goes from end-to-end life cycle of the whole machine learning model, and it provides one endpoint that we can directly use in our production. And yeah, this also more we can discuss the more see the models and deployments right here. And there are also some quick start solutions, like if you don't want to spend more time, you can just start an automated machine learning by the quick start. And yeah, this is the whole diagram that how we can provide a solution with AutoML. So first our data will be in Amazon S3. So that will be in the buckets. And we provide the training data and evaluation data, and that can be triggered from Lambda. And after the autopilot training job is done, it call back the step, and it checks the job status. If it's completed, then it processes the model evaluation after it's done. And after that, it does the lambda step and register the step. So after choosing from all the models that are being developed in the Amazon, like a SageMaker, it will register the best model in the model registry, and it will deploy a script that can be used further in the production area. So it will create a model endpoint. So starting from just the basic of the data, it provides the model endpoint. That's the whole solution that we looking for any ML project. So it does really great. Yeah, this is the Azure AI. So Azure AI also provides many services like other than AutoML, bot services, cognitive search, video metrics, and document intelligence, everything. But it also works well with automated ML. It gathers the data, optimization metrics, and constraints, and that's the automated machine learning. And yeah, this is the larger, like the inside what's happening in the AutoML. Like uh, we can check it for the image data set. So it gathers we can store our images in blob stores, which is a service in Azure, and we can have it on the data store that is used to connection the string to blob storage to the data set. And after we gather all the data, the tabular data and the image data, after labeling that project, it runs multiple nodes, and it checks as the same similar as the SageMaker Studio. It checks all the models on different nodes and do the parallel programming, and it can also use for the model tuning and hyperparameter ranges, optimization of metrics, and early termination policies if we set anything for budget and compute. So often there are many services that run for longer time, and it also runs like for a longer time and finds the best model. So we have to be cautious and just provide the termination policy and time, also budget to control our usage on AutoML. And yeah, after that, all the getting all the models, it gets the best model for deployment, and that's how the Azure AI works for images. And also there is Google Cloud for text AI. I don't think many people prefer to use AWS and Google for automated machine learning. So it also does the similar jobs, that getting the data, and it's end-to-end no code. So we just have to select the features and it will be done by itself. And yeah, these are some of the services provided by Vertex AI, like notebooks, pipelines, hyperparameter tuning, feature store, and most importantly, the AutoML and the model serving. So for infrastructure and cost implications, as I said, if we want to use AutoML, we have to configure it on AWS or any of the cloud, and that uses a pay as you go model. So that's determined by the instance type, duration, and data storage that we have for our model deployment. So in most of our cases, if we do the manual work, then we can just have the normal instance type, and it can run for longer duration and it's very time consuming. But in AutoML, we can just set it on the auto scaling, and then it does everything on its own, and we don't have to select any instance type and worry about the duration and data storage. So it's managed infrastructure that supports a variety of instance types and scaling options, and endpoint auto scaling, that as I said. For cost optimization, we can run spot instances. So spot instances are basically the budget instances provided by any of cloud. So while it runs when it's available. So if it's a lower cost, so there are few of the spot instances available. So whenever that is available, and you can just schedule your job, and whenever that is available, it will be done by that time, and it saves a lot of cost, because uh, we don't use the our own dedicated instance, rather than we use someone else's instance for a smaller time. And yeah, we can also set monitoring and auto scaling, data pipeline optimization, also careful use of the notebook instances that can optimize our cost. Whenever we provide our notebook instances to students, we tell them to just use it when they are working on. Otherwise, they can shut down the instances, and that uses a very less amount of time. So it's a really cost optimized setup that we have. And also the fine tuning parameter jobs, and implementing lifecycle policies in S3 does improve the cost efficiency in any of the cloud. And the most important part, that why not everyone is using AutoML. Like we saw that everything is done by itself and we won't need any data scientists. So these are some of the limitations and some of the challenges that have for AutoML, that we can just go through, that why not everybody can use it. And it says it helps to automate the machine learning tasks, but it also has limitations. Some of that are not getting accurate results and are dependent on high quality label data, and demanding attention to the data quality. So as I said, that it does everything on its own, so it needs high quality label data. So if it's not that much structured data, it might not give you the proper outcome that you're looking for. So the trade-off between automation and model customization also is the challenge that in many cases, if we are not familiar with the model that is being used by AutoML, it will be hard for us to just do the manual intervention and just edit the stuff. Then we have to just create a different model and buy ourselves and then do the modifications. So yeah, that is the also one challenge. For AutoML, it automatically uses high-end instance for training and automatic model deployment. So while we are just developing a model, there might be some cases that we just want it to run for 1 hour and get the results, but it's a high-end instance, so that's why it's going to cost more. So we need to set up a few parameters before we set up the AutoML. So that's it or doesn't automatically use the high-end instances. So while the default behavior is to be efficient for some case, as I said, like if we have multiple models, we can use high-end instance and it will be done in smaller time, but it may lead to resource overuse and also unnecessary cost. So not every scenario necessitates to model deployment or use any kind of a high-end hardware and prompting to need strict policies to limit those AutoML usage. So that is one side of the infrastructure setup that we have to do. So we don't get much of the higher side of the the higher spend that we are than we are given. So the customization is required to align with the resource allocation and with the project requirements, ensuring the optimal efficiency and also the cost effectiveness. So yeah, these are some other limitations of AutoML. So that's the lesser understanding and can be out of scope and increase complexity. So as if we provide any unstructured data and that is not very labeled, highly labeled, then sometimes it's get confused and it goes out of the scope. It has a high scaling cost, non-specialized generic models we cannot use in that one, and non-existence of reusable components. So as I said, if the model is not familiar to data scientists working on that project, they cannot use it after it done in the AutoML. And if they want to do any modification, it will be harder for them. So yeah, we can also export the Python notebooks, but as I said, it's very might be generic and lacking in detail to work on the modification side. And yeah, it will be very hard to someone who is not expert in this field to identify the specific algorithm and that is used in this one. And it comes to that it complicates the understanding of AutoML's decision making. So these were the some of limitations of AutoML, and also there is one limitation that I haven't mentioned here is the data privacy. So most of the companies have their data secured in their uh, own cloud or local host. So if they provide data to AutoML, then they have to look into the AWS or any of the clouds policy that how they are going to use that data, because doing AutoML, they need to read all the data and then after work on the automation of whatever they are going to do in the modeling. So that is the also crucial thing to check before you go ahead for AutoML. And yeah, the standard question that we all might have that will AutoML replace data scientists? So as you see, the answer is no, because while the AutoMLs are good at building models, they are still not capable of doing most of the data scientist job. We still need the data scientists to define business problems and to apply their domain knowledge and to generate more useful features. So currently, they don't have any capability to build recommendation and ranking models. So there are few of the there are a few of the companies that uses the AutoML, but they have to every time struggle with they have to hire a data scientist to make doing the analysis stuff on that AutoML model. So it's not that much of uh, industry ready right now, but we can just still use it, and data scientists can save a lot of time by using AutoML. It's just that they have to be aware of whatever they are doing and select the proper implications that they are going to do in that machine learning model. And the future of AutoML. So as you can see, the in the graph it says that automated machine learning's market global forecast to 2028 is like 6.4 USD, so 6.4 billion USD. So right now it's very on the lower level, like 1 billion or something. So it will go 44.6% hike by 2028. So the future is expected to improve the model interpretability and leading to increase the trust in automated decision making. It's also the collaborative and federal learning approaches to decentralize the data insight. So as we go through, when there was no AI, we was seeking AI, and nowadays the AI is very in high demand. The same thing will also happen with AutoML, that AI will also help AI to get better self. And the integration of domain knowledge and increased automation feature engineering to improve the model performance, as we know that it will be evolving by time. So yeah, and now we can just head over to AWS and have a demo on how we can use AutoML.
We've got a couple questions. Do you want to take those before you start the demo, or do you want to take them after the demo?
Yeah, I can just show a demo. Then maybe if there's more questions from a demo, then we can ask.
Okay, sounds good.
Yeah. Let me share. Yeah, can you see?
Yeah, we can see it.
Okay. Yeah, so this is the SageMaker Studio, and this is basically a personal studio that you can deploy on a SageMaker domain. So this is the domain ID of the studio, and it's a Jupyter lab that we have on Jupyter Notebook. We can also open a lab, but it's a little bit advanced and have really more features than that's available on the Jupyter Lab. So we're gonna go to AutoML, and this is the basic thing that we have to do. First, we can just create the AutoML experiment. We can type in as anything that it's testing. And I have already stored the data in S3 bucket. So we just have to browse our S3 bucket and select it from the drop down. Yeah, so So we have a car price prediction data set here, which I got from Kaggle, and we can work on any of the data set that you have, and you can just store that onto S3 and give a path, and then it will be ready to go. So right now we have selected the data set location. Now we have to select the target column. So what we want to do is the price prediction of that car. So these are the columns that are available in that CSV. So we just select price as a target column, and we can add any sample weight if you want to. It's optional, but some of the ML modeling that needs to that needs with the value of that weight, and we can just add that from here. We can just have it on automatic and just go to next. And here we can choose if we want to do other than the automated machine learning, like we can select different models from here, that if you want to use all of that 8, it will be doing parallel processing and just have everything ready for us and find the best model. And same goes for hyperparameter optimization. It does it for all the available models here, and we can select one or maybe two of them. It will select the best of out of everything. So right now we can just go with automatic, so we don't have to worry about anything. And then after we can just write any deployment name. So after we just have it on auto deployment, there's also various options that we can select from any machine learning problem, that if it's a binary classification, regression, or multi-class classification. We can also keep it on auto if we are not that much familiar with it. And we can also choose runtime from here. So right now we have set everything on automatic, so we don't have to do anything of that. And we have these are some of the back-end things that you might not need to worry about when you have everything provided by an organization. So we can also create any tags to just figure out which of the services that we use and which of the resources that are being used in this one. And we can just review and create. So it will create one endpoint, and here it will do the testing models and provide the report here. Yes, it will take a little bit of time, like more, maybe 15-20 minutes, depending on the data set and everything. But this was the basic AutoML demo that I have to show everyone, that how it's worked. And it's very simple. You just have to select a few of the resources that you select from uh, while doing the AutoML. So just selecting the data set and selecting target value. That's all. Otherwise, you can set everything on auto and it will doing by itself. So yeah, that was it for me. We can go through any questions if anyone have.
Yeah, thank you so much for your presentation. I found the infographics and all the visuals you had were very helpful in kind of understanding everything. We've got a question in our question and answer box. Do they charge for data transfer? And I'm assuming they is like the cloud platforms. You can correct
Yeah.
me if I'm wrong in the question box or in the chat.
Yeah, so for data transfer, basically, as I said, we have to store everything on cloud. So if you have on-premise data, then we have to move that on cloud. And for that data migration, we just need one person to work on. So we'll need some resources to work on that to do the data migration. Other than that, I don't think there is any extra charge, just the charges for transferring the data. Like if we are using any instance in between, that's being charged. Otherwise, it's very minimal cost to transfer all the data. But for storing on cloud, we have to pay uh, the per GB or per monthly cost for storing the data.
Awesome, thanks. And I've got a question myself. How does AutoML handle imbalanced data sets?
Yeah, so as I said, it sometimes it does get confused if we have imbalanced data, but it also typically use resampling techniques and specialized loss functions during the model training to handle imbalanced data set. So these methods aim to give equal weight to all of the classes and prevent model from becoming biased towards any of the majority classes. So it's important to configure the AutoML tool to apply these techniques appropriately. So after that, we can have better model and doesn't make any confusion to AutoML. But yeah, it can do handle well with imbalanced data sets.
Okay, interesting. Thank you. I don't see any other questions in the chat, but now's your last chance to, if you have a question. Oh, we've got one more in our Q&A. Is there any way to use DL models, which I'm assuming is deep learning models? And if so, is there a way to add layers?
Yeah, there are, as I showed you in the demo, that we can also select the different models. For deep learning models, we can also configure how many layers we want, and it's possible in AutoML. So you just have to click buttons, and that's all. Yeah, we can do that.
Okay, good to know. Thanks. I don't see any other questions, but we can give it a few minutes as they come in. I do have some more links to share in our chat here. Oh, we've got one from Amit. Is AutoML itself a machine learning model, or is it more of an if-else algorithm?
No, it's just the it has some algorithms in backend that uses the traditional ML algorithms. So as I said, it uses multiple algorithms and do parallel programming and use out of that all of the algorithms. It select the best algorithm that is available for our data set and do the modeling. So it doesn't have it by itself, but there will be backend programming that is being done by AWS or any AutoML platform, and yeah, so that is done by themselves.
Okay, thanks. I think there was one more person that had their hand raised, so if you wanted to go ahead and unmute yourself now, you can. But if not, I've got a few more links to share in our chat that I'll share right now. So I've dropped the links for our student pool and also our mentorship program, which is called STEM Connector, and it's a Flash mentorship program that if you're interested in connecting with folks working in the ocean sector or connecting with other students like yourselves, you should totally sign up. It's free. It's a Flash mentorship program, so you can connect with all kinds of different mentors, and it's more of one-off meetings that can be done virtually or in person. And if you enjoyed today's discovery session, we also have plenty of other discovery sessions available on our YouTube channel. So I've also dropped the link for that, as well as all of our social medias. And keep an eye out for more discovery sessions and events from us. We've got 3 more discovery sessions happening this semester. So we've got one more on cloud as well, and another one on generative AI. And the last one will be a surprise. So we've got, oh, I see one more question in the chat here. For a beginner, which cloud provider would you recommend to work on AutoML?
Yeah, for beginner, I would also suggest AWS because it is the most advanced that I have used till now. I have also used Azure and Google, but we can also have any students credits that are available in AWS, and we can just use that, and we can just play around with the AutoML on AWS. So it's very easier and many more options available in AWS rather than others. So I would recommend AWS.
Awesome. And with that, I think we'll wrap up. Thank you again so much for taking time out of your day today to join us, Prakrut, and all of our participants. And we look forward to seeing you at the next one. Have a great day, everyone.